Welcome everybody on my session, and thank you for finding time for that. My name is Pawel Rzepa, and today I'd like to present you some attack vectors and mitigations. So, what can you expect during this presentation? Firstly, I will show you some differences in running function as a firstly, I will show you some differences.
Pawel, I think you may have the live stream YouTube in the background running.
Function as a service using services from various providers like AWS, Azure, and GCP. Then I will present my little research regarding dependency poisoning. Furthermore, we'll go through an attack called denial of wallet, which is specific to all cloud applications. Then I will show you the problem of secret leaks from serverless applications. And next, we'll go through the real plague of serverless that are over-permissive roles. And lastly, we'll go through the problem of dangling resources, which actually motivates me to make this presentation. Before that, let me introduce myself. My name is Pawel Rzepa, and I work as a senior security consultant in Securing in Poland. And on a daily basis, I perform cloud security assessments as well as application penetration testing. You can find some of my articles on my Medium blog, and from time to time, I share the latest news from cloud security world. So if you're interested, I encourage you to follow me on my LinkedIn and Twitter accounts. For all those of you who are not familiar with the concept of serverless, let me quickly explain it to you on a very simple example. Imagine that you run your own blog for some time using just a static content like HTML, CSS, and JavaScript. Then you decide to put there a buy button to sell your course. That means that you now have to confirm that the customer paid for your course by implementing a webhook and handling the confirmation from the payment provider. Then you have to send an email to your customer with the access token to your course, right? And finally, you probably would like to get a daily report regarding how many courses you've already sold. If you're using only static content, so far that brings some challenges. You have to refactor your website to manage dynamic content and refactor your code. What is more, you don't know how big traffic you will have, and you have to pay for hosting based only on your assumptions of the traffic. And finally, you have to maintain your server by yourself. That means that any patch management on the operating system or any latency issues are on your side. In the opposite, if you choose the serverless architecture, it fits well to such case, because the only thing you have to do is adding just free function as a service where you are completely focused only on functionalities without any maintain stuff. So the serverless means that you don't have to worry about what server your function as a service is running on, because that is handled by a provider, so in this case, Amazon. The code execution is triggered by an event, and there are various event sources. For example, it can be uploading a file to your S3 bucket or an HTTP GET request to your API gateway. The event triggers the runtime environment and executes the Lambda function code. Lambda functions work as a lightweight micro virtual machine based on Amazon Linux image. If you're interested to find out how does the Lambda environment works, you can just visit lambdashell.com, and the project gives you a shell to Lambda environment without a need to have the AWS account. So, for example, here you can see that the code is stored in the var task directory. But what is so there is the full source code of your Lambda function. But what is more interesting from the security point of view are the environment variables, because there are all the secrets in the plaintext, as well as the AWS access keys to the execution role that is attached to this particular Lambda function. So every instance of the Lambda function requires a role with assigned permissions, which is called the execution role. For example, every Lambda function needs privileges to put logs to CloudWatch service, or your Lambda has to be authorized to put or read an entry in DynamoDB. And this is done by assigned execution roles. One more important thing is that each Lambda function is sandboxed, so it is separated from other functions. In Azure, functions are deployed as app service. So for example, to deploy them, you have to also deploy the storage account where your functions are stored. What is more interesting is the fact that all the functions are deployed in the same app service. So they are sharing the whole runtime environment. So you can see on the slide here that there are 3 Azure functions, and only 2 of them are HTTP triggered, and 1 is triggered by a timer. So for example, like running the Azure function once a day. Now, let me show you an example. So here in my app service called Azure Shell Demo, I deployed the demo shell function, and using the CMD parameter, I can perform any command on this environment. So surprisingly, Azure functions are running on Windows. However, on Linux, it is also possible, but it is not so common. In the directory that is home site www.root, you can see that there are all 3 functions. So let's go to one of it. So here you can see that there's the function JSON file where there is all the configuration regarding this particular function. Like, for example, if you can anonymously access this or not, or you require a token. In the run CSX file, you can see the source code of this demo shell function. And again, let's print out all the environment variables. In the Windows environment, we are doing it using command set. And again, you can see that all the environment variables, including secrets, are in plain text. So any login pass to a third party, or for example, the connection string to your storage account, which is very important, which will be very important in the next slide. So please remember it. So what about the GCP? Here I'm running the Netcat listener on the lead port, and then I'm running the GCP cloud function to get a shell. And surprisingly, all the GCP functions are run on the root account. You can also print out the environment variables, which can store the environment variables, but there are no access keys like in Lambda shell. To access the keys, or rather the token, which is assigned as an execution role to this particular cloud function, you have to use the metadata service, which is accessible under the others 169.254, 169.254. And this is the link local address, what means it can be accessed only by the cloud function. And the difference with to the Lambda shell is that you have to AWS at all, you have to put a header called metadata flavor. So if your cloud function has the server-side request for the vulnerability, it is hard to just get the token, but because you have to add this header called metadata flavor. So let's see, you can print out the scope of the permissions of the service account that is attached to this cloud function. And you can see that by default, all the cloud functions are having the editor role, which means almost like administrator. The only difference between the owner is the fact that the owner can also manage the billing service. And what is very interesting, you have the, by default, you have the permissions, the editor role to cloud platform, what means you can do basically anything. Like read, write, anything. So to access a token, so simply access the metadata service and the endpoint token. And with this token, you can now authorize yourself using the, for example, the G-Cloud CLI and do arbitrary action. Okay? All right. The main character of the story I'm going to present is Bob. And Bob is a junior developer who has recently started programming serverless applications built with Lambda functions. His applications are developed in the test environment and they will be used only internally. So absolutely nobody cares about any security testing or any special isolation of this code. Which is pretty common approach, unfortunately, because in the monolithic architecture, everybody thinks that you cannot access those internal applications from the public internet. However, in serverless, the situation looks a little bit different, what will be presented in the next slides. Furthermore, Bob uses serverless framework, which is the most common way to deploy the applications in AWS. The serverless framework based on serverless configuration file generates the CloudFormation templates and also zip your Lambda functions with all the dependencies. All those steps, of course, can be done manually, but the serverless framework automates most of such steps and makes developers' life much easier. So let's go through the first attack that is called dependency poisoning. Let's take a look on Bob's first challenge. Files uploaded to the particular S3 bucket should be automatically renamed with some prefix. So the idea here is simple. Once the file named test new PNG, for example, is uploaded to S3 bucket, the event triggers the Lambda function, and the event is basically a JSON file where you can find such information as name of the bucket to which the file is uploaded, or the name of uploaded file, and then the Lambda code should rename the uploaded file and remove the old one from the bucket. Hope it is clear and easy for everyone. Like many other developers, instead of writing the code from the scratch, Bob started searching for the ready-to-use code. So he searched the internet through the places like Stack Overflow or npm.js repositories. And luckily, in npm.js repository, he found a package called s3 rename. And analyzing its usage in a README file, Bob found that it is exactly what he's looking for. That is, it renames the S3 object. So Bob writes the following code. As you can see, he extracts from the event.json file the name of the bucket and the name of the uploaded file here in this line, and then he takes the name of the old file and put the scanme prefix. And all of that is done by the s3 rename method from the s3 rename package. After uploading the file test new PNG, Bob sees that the scanme prefix is added. Moreover, in the CloudWatch logs, everything seems to perfectly work. So Bob is super happy how easily and quickly he was able to finish this task. But when we analyze the s3 rename package source code, we will see that there's a line with obfuscated JavaScript code. This line of the code basically does the following. Verify if there is the AWS access key ID environment variable, and if so, send it to the attacker's server. So the developer is totally not aware that his Lambda function is sent the sensitive data like the AWS access key ID. To be honest, I've created the s3 rename package and published it just for the demo of this presentation. However, there was more than 500 downloads of this package, and on my server, I've received not only Bob's AWS access key, what means somebody else was also using this package like Bob, what is pretty scary. Of course, the s3 rename package is no longer available in npm.js repository. However, unfortunately, there are no mechanisms preventing you from putting the malicious code. And such attack would also work in GCP and Azure. Can we do anything to defend against such attacks? First of all, by default, Lambda function is executed outside of your VPC. However, you can run VPC-enabled Lambda function in private subnet. And then, using security groups, you can control any outbound traffic. If you need access to any of your AWS resources, like, for example, DynamoDB, you can use the VPC endpoints to communicate with them, and any traffic is not going out of the AWS infrastructure. And similar defense approach can be done in GCP and Azure. Now, do such attacks happen in real life? Let me tell you the story about the dependency poisoning in a very common NPM package called Event Stream. Event Stream is kind of a toolkit to handle streams in your application. It is a very popular package with almost 2 million downloads weekly, at least at the moment of doing this screenshot. And it is broadly used among many various applications. The package was developed and maintained by Dominic Tarr. Dominic is an experienced developer who's released many open source packages. 3.2 thousand followers, as well as the amount of his contributions to open source projects, seems to be a reasonable argument to trust this guy. However, at the end of 2018, it was found that one of the event stream contributor with a nickname Right9Control added malicious code to the event stream. Dominic Tarr replied. He emailed me and said he wanted to maintain the module, so I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore, and haven't for years. So let me repeat the scariest thing here. He emailed me So as you can see, gaining permissions to push arbitrary malicious code to the dependency used by thousands of other applications is as easy as sending an email with the direct request. So what did write9 control do? He added the malicious code as the dependency of the event stream package, which was called the flatmap stream. Then, only when copy dash package was found in other dependencies of the application, the malicious code was decrypted and executed. The copy dash is a popular Bitcoin platform. So, as you may already guessed, the goal of the malicious code was to steal Bitcoin wallets. The whole attack was uncovered for 48 days, and the only reason why it was detected was sheer luck. Because one of the methods used by flatmap stream became deprecated. So all the applications that used the event stream with the malicious flatmap stream dependency were notified about the deprecated method, and this was the method related with crypto. So people were pretty scared that they are not using any crypto. So why those warnings are coming to them? There's a really nice write-up regarding this story. So if you'd like to read it in details, check it out under this link. Please be aware that such attacks can happen in any dependency of the dependency. So for example, you can see the event stream in latest version has just 7 dependencies. However, there are other packages, like for example, Express package. Which has much more dependencies. So if you're using Express framework in your application, then a malicious code can be injected through any of those dots. Pretty scary, huh? Regarding defense, there are available various tools which tracks any known vulnerabilities in dependencies, and the most popular are Snyk and Black Duck, and the open source OWASP dependency track. You can also run npm audits to detect any known vulnerabilities before releasing the application. And there are also for Python projects, similar thing can be done using the PyApp, and for .NET projects, you can use a tool like .NET Retire, and you can find them in GitHub. So let's go to another attack, denial of wallet. The second Bob's second challenge is to add functionality that only some extensions should be scanned. So Bob again searched through the internet in search of the proper regular expression, and he combined few of them. And after several tests, it seems that everything works good. So let's analyze this regular expression. As you can see, the word test correctly doesn't match. The word test PDF also doesn't work, which is also correct. However, if we call the file like with numerous A letters, we can see that we face the catastrophic backtracking. And let's take a look on it. In this particular regular expression, the regex engine can make various decisions. So if there's no match after analyzing whole string, the regex engine goes back to the previous point where other decision could be made and keep searching. If there's again no match, then the regex engine again goes back and makes different decision. In consequence, there are so many checks that it consumes all available memory. And most of regex engines support backtracking. However, not all of them. For example, in Go language, the REDOS attacks wouldn't work. So if you're using the serverless framework, then the default timeout for your Lambda is 6 seconds, what can be extended to 15 minutes. In Azure and GCP, the default timeouts are 5 minutes, which can be extended to 10 minutes. What you should know about pricing is that you are billed not only for the amount of requests, but also for the computing time. And it also depends on the allocated amount of memory. So sending 100,000 requests may do a significant financial loss, like 100,000 requests, each billed for 15 minutes, then it will cost around $1,500 of US dollars. And regarding pricing, there are no big differences in Azure and GCP. There are, like GCP is almost twice more. However, you have for free, instead of 1 million requests, you can send 2 million requests. So in general, we can say that there are no big differences between the providers. If you're unsure regarding your regular expression, it's always a good thing to check them against DDoS attacks. And there are many available online tools like DDoS checker search.sh. And by just pasting the regexp, you can test it if there are possible DDoS attacks. So what you can do to protect against such attacks? You can adjust Lambda concurrent execution limits, so not to allow to run too many Lambda parallelly. And also you can put the throttling limits in API gateway. Furthermore, you should track anomalies in logs, and you can also set up a billing alarm. So if there are any anomalies, you should be quickly notified that something is not okay and it requires your attention. Now, let's go through the secrets leak. The Bob's third challenge is the Lambda function should create a new entry in DynamoDB. A very common practice that I can observe in my commercial cloud security assessments is that a lot of developers store secrets in plaintext. But you should be aware that the plaintext secrets aren't stored only in the Lambda function configuration. If you are using the serverless framework, the configuration with plaintext secrets is stored in S3 bucket, which can be accessed by anyone in your AWS account who has the read S3 permissions. So when you analyze the automatically generated bucket policy, you can see that there is no restrictions who can read the objects in this bucket. So if an attacker compromises one of your AWS user with limited permissions to just S3 read action, which is pretty common, it is possible to read all those secrets and then perform further attacks. To prevent such leaks, remember always to store your secrets encrypted. And if you use AWS Secret Manager, then you can refer to those secret values using the following syntax. And very similar approach is in Azure, but the secret manager is called the Key Vault, and in GCP, it is also called a secret manager like in AWS. One thing to point out here is the official Azure documentation, where you can find such information that secrets are always encrypted when stored by default. But this is partially true, and some developers may mistakenly think that they do not need to encrypt those values. because every user in your Azure tenant who has the access to app service can simply just display them in plain text. Furthermore, what is less obvious is the kudu service, and the kudu service is running on the top of app service, and it is used, for example, for debugging tasks like dumping memory. And if you access this kudu, if you have the access to kudu, then you can print out all the environment variables. And among those environment variables, you can find also the connection string to your storage account. And using storage account, you can upload an arbitrary function which displays all environment variables. Let me show you an example. So here, I'm trying to run the function which is called pwned, and obviously it will not work. I have the 404 error because there is no such function. However, if I compromise the storage account inside www root, I can see all those free functions. But what I can do is just upload an arbitrary new function. So I call it pwned. And as you can see, there is the function JSON with the configuration of this function to be accessible anonymously. And there is there's the code to simply print out the environment variables to know all those secrets. And now you can see that all of them are accessible just having the access to storage account. And based on the documentation, so somebody may think that it shouldn't be a problem because in the storage account, the values are always encrypted. The secrets are always encrypted. And now time for the really plug of the serverless applications, that is the over-permissive roles. So Bob has the fourth challenge: create the proof of concept application where internal candidates from his organization can submit their CVs. So here is the little demo. The static content is in Polish, but it is not important. You can see that there is the link to CV in doc file, which I'm sending to the server. And after sending my CV, I can see the confirmation that thank you, we just received your CV. But if we just do a very simple fuzzing, like adding the semicolon, we can see that actually we have the remote code execution here because there is used the cat-doc program to process this file. So if I add the env comment, all the environment variables will be printed out. There are some errors, but it is not important because in the bottom of the output, you can see that I have the access to the session token, to the access key, and the secret access key. So all the information needed to use the function role that is execution role that is attached to this particular function. So just to visualize you what happened, an attacker was able by sending the crafted HTTP request to the API gateway. It triggered Lambda, and using the remote code execution, it was possible to get keys to the execution role that is assigned to this Lambda. So a user can do anything in what is allowed by this particular role. But the problem is that those roles are very, very often over permissive. And it happened sometimes when I was looking why it happened, what is the reason. So one of the argument is, for example, if you are using the serverless framework, and just a reminder, it is the most common way of deploying the Lambda functions in AWS. There is by default you are sharing the IAM role across all the Lambda functions. So assume that only one Lambda function requires permissions to DynamoDB and S3 actions, and two others, and in one other Lambda function, there is the remote code execution vulnerability. And although this vulnerable Lambda function doesn't require the permissions to DynamoDB and the S3, it still have, because you deployed one role via the serverless framework for all those three functions. So what you can do is to use the plugin, which you have to explicitly install. And this plugin is called Serverless IAM Roles per function. And thanks to this plugin, you can create a role per each function. So in this particular case, you can create a role just for one function, and the attacker with vulnerable Lambda couldn't do much, at least nothing with the permissions with this role. But what if you can access resources only from AWS Lambda? In other words, if you are trying to use the access keys that you've just extracted, then sorry, but it is not allowed. So let me show you what attacker can do in this particular case. If the attacker has the remote code execution, it's still game over for you. So here, remember about the URL encoding. This is why those why you can see it here. And I'm just printing out the listing of the var tasks. So as you remember, there is the source code of the Lambda function. And if you using the command cat, you can print out the source code of this Lambda function, and you can see there that there are some actions regarding DynamoDB. So it is pretty obvious that this role needs some permissions with DynamoDB. So remember that it is the runtime execution environment for Node. So you can simply put a Node code to do anything from the Lambda inside of your Lambda function, inside of your AWS environment. So here I need to encode this. It is not required to encode all the characters, just the key of them, but yeah. So by putting it, I was able to print out all the content of this DynamoDB. And by the way, this demo comes from the serverless goat, which is a vulnerable serverless Lambda function, accessible from the internet. There's no need to set up your own AWS account. So yeah, you can find it on the serverless -hackme. So yeah, have fun. This is not only the vulnerability of it. So what you can do to protect? Well, the most important thing is to follow least privilege principle. Use per function IAM role. So always limit every function to only actions that are really required. you should also harden your API gateway. There's something called the API gateway request validation. So, for example, if you are expecting only the string value, you can set up such validator, and any tries of remote code execution with the node source code, it wouldn't work. And the interesting things are in GCP that, as you remember from the beginning, by default, all cloud functions are run under the same service account with editor role that allows you to access everything. So you have to explicitly create unique service account per each function to limit their permissions. And in Azure, you should apply the role-based access control to limit the permissions. They are less granular than in AWS. However, you can also use the shared access signature tokens to get limited access to other resources. And this is the theory, because in reality, there are still developers who will just sit an additional work in all those steps. And they still believe it is just for internal usage. So there's no point in securing absolutely every function as a service. And this brings us to the last problem I want to touch, and this is the dangling resources. So, as you may remember from the beginning of the internet, a lot of server rooms looked like this. So totally mess, but all in all, it worked. And when we migrated to cloud, I think that the situation is pretty similar, because when I'm doing the cloud security assessments, there are a lot of unused resources. They're the resources which were used for years, but they are still accessible from the internet. And remember that finding dangling HTTP triggered function as a service is as simple as enumerating subdomains. In AWS infrastructure, you should look for the execute API endpoints. And in Azure functions, this is also quite funny, because by default, all those functions, HTTP trigger functions, they are also accessible using the HTTP. So you have to explicitly turn off the HTTP without encryption. And in GCP, you can also find some available endpoints to access the cloud function. In Azure, you can see that there are at least two ways of accessing your function. And one way is to use the API key in the header, which is called the xfunctions key, but you can also put the same API key as the get parameter. So if you searched through the Wayback Machine that is accessible under the URL webarchive.org CDX search, you can simply find a lot of Azure functions with the code parameter. So here, for example, you can see the PRD letters may point that it is the production function with the get token, and the get token is reflected, and all of it is accessible for everyone who is searching the Wayback Machine. And of course, the Wayback Machine is not the only source of such juicy information. So remember to regularly audit your cloud infrastructure and remove all not used resources, because any of them, they are potential entry points for attacker to your infrastructure. So To sum up, let's go through all those what I said in this presentation. So firstly, we went through the dependency poisoning attacks. Then we went through the denial of wallet by RDoS attacks that are still a threat in serverless world. Furthermore, there are leaks that can be, for example, by printing out the environment variables, but more common would be to find those secrets in the buckets. And people are often not aware that those secrets are stored in the plain text, and everyone in their organization with the S3 read has access to this. And finally, we went through the over-permissive roles that allows you to often hacking just one function is enough to compromise your whole infrastructure because of privilege escalations and things like that. Because gaining an access to the cloud is just a beginning. And if you are curious what can happen later with the access, what attacker can do, and you want to see the full cyber kill chain in AWS, please visit this link. There is my presentation from previous year. So I hope you will like it. Okay, so we're going to the end, and if you are interested in taking such cloud security assessment, or you have any questions regarding this, I'm doing it on a daily basis. So please just ping me, and I will be very, very happy if you can share feedback regarding this presentation. Do you like it? Do you think it is missing something I should add or modify? I will really appreciate. So thank you very, very much for your time, and wish you all the best.
Thank you, Pawel. I'm looking at Slido, and sadly there aren't any questions on there. So let's see. There is one question in a side channel that I got, and they're asking, since a lot of the things you discussed here are are Azure specific, is AWS, in your view, better?
Could you please repeat?
Since quite a few of the subjects the examples you mentioned were Azure specific, do you consider AWS better?
No, I don't want to say that any provider is better. There are big differences. There are differences between them. However, all the attack vectors that I presented, they can be mitigated in every provider. The problem is that it always requires your additional steps, and this, I think, is the main blocker why many developers are not doing it. I think that it would be better on a very specific case to choose what is better, because which provider is better for this particular case, because there are some different limitations required regarding the concurrency of function as a service or giving the granular permissions. But generally, I think that it would be, I cannot say that any provider is better, and I don't want to do it.
Okay, fair enough. That is the only questions we had. So, something popped up again. Will you release a guideline for securing installations?
Securing installations like deployment of serverless applications?
Like a best practices document or a Medium post or a white paper?
Yes, there is already accessible on Medium one general, which is more focused on AWS. I didn't think about making it, enhancing it for GCP and Azure, but well, yeah, it is, yeah, that's a good idea. So it will be on my to-do list. If you are interested, I'm planning in August to share the article regarding something different, but also very, very interesting, that are the HTTP request smuggling attacks in cloud. Because surprisingly, they work by default when you are using the cloud load balancers, for example. But it will be, with details, it will be on my Medium. So if you're interested, just please look on it at the end of August.
Okay, and I trust that when it's there, you will put a tweet out or something so people know, we have to look.
For sure.
Okay, awesome. Okay, I guess that's all then. Thank you very much, Pawel.